come here. Get cozy. I've got something really special for you tonight. We are going to walk through some of the most beautiful ideas in mathematics. And I am going to show you that every single one of them makes sense. Every single one of them is something you can understand. So before we start, let me give you a little taste of everything we are going to cover. First, we are going to play with algebra. And I do mean play. We are going to solve equations like 5x minus 7 equals 23. And you are going to watch that x reveal itself to you like a little secret. X is 6, by the way. 5 times 6 is 30. 30 minus 7 is 23. See, it just works. Then we are going to explore fractions, not the boring kind. The kind where you can actually see what is happening. Like, imagine a pizza cut into 6 slices. You eat 2 of them. What fraction is left? 4/6, which simplifies to 2/3. We will talk about why. After that, we are going to step into geometry. Triangles, circles, the areas of strange shapes. We are going to calculate the area of a triangle with a base of 12 and a height of 9, which is 54 square units, half of base times height. Simple and elegant. Then trigonometry. We are going to use sine and cosine to figure out the height of a tree without ever climbing it. If you stand 50 feet away from a tree and look up at an angle of 60 degrees, that tree is about 86.6 feet tall. Trigonometry tells you that. From the ground. No ladder needed. And we will finish with quadratic equations, the ones with the x squared in them, the ones that draw parabolas in the sky. We are going to factor them, graph them, use the quadratic formula, and watch them come alive. So settle in, pull the covers up, close your eyes if you want, and let us begin. Okay, algebra. Let us start here because this is the foundation of everything. And I want to go deep tonight, deeper than last time. I want you to really feel how algebra works in your bones. The whole idea of algebra is balance. An equation is a scale. Whatever is on the left side weighs exactly the same as whatever is on the right side. And our job is to isolate the unknown, to get x by itself, without ever tipping the scale. Let us start with a warm-up. X plus 9 equals 15. We want x alone, so we subtract 9 from both sides. X plus 9 minus 9 is just x. 15 minus 9 is 6. X equals 6. And we can verify. 6 plus 9 is 15. The scale balances. Good, now let us add a layer. 4x minus 3 equals 21. 2 operations are happening to x. It is being multiplied by 4. And then 3 is being subtracted. We undo these in reverse order. First, undo the subtraction. Add 3 to both sides. 4x minus 3 plus 3 is 4x. 21 plus 3 is 24. Now we have 4x equals 24. Divide both sides by 4. x equals 6. Check it. 4 times 6 minus 3. 24 minus 3. 21. Perfect. Let us try one with x on both sides. This is where it gets interesting. 7x plus 2 equals 3x plus 22. There are x's on both sides of the equation. We need to gather them together. Bring all the x's to one side and all the numbers to the other. Let us subtract 3x from both sides. 7x minus 3x is 4x, so we get 4x plus 2 equals 22. Now subtract 2 from both sides. 4x equals 20. Divide by 4. X equals 5. Let us check the left side. 7 times 5 plus 2. 35 plus 2. 37. The right side. 3 times 5 plus 22. 15 plus 22. 37. Both sides equal 37. Balanced. Beautiful. Now here is one that trips people up. Equations with parentheses. 2 times the quantity x plus 4 equals 18. That word quantity means the parentheses wrap around x plus 4. So we are multiplying the whole thing, x plus 4, by 2. First, we distribute. 2 times x is 2x, 2 times 4 is 8. So 2x plus 8 equals 18. Now subtract 8 from both sides. 2x equals 10. Divide by 2. X equals 5. Check. 2 times the quantity 5 plus 4. 2 times 9. 18. Yes. Distributing is like handing something out to everyone in a group. If you have 2 gift bags, and each bag has x plus 4 items inside, then the total is 2x plus 8. You gave 2 to x and 2 to 4. Everyone gets their share. Let us do a word problem. Because real life is full of algebra, you just do not always notice it. Say you are saving up for a new pair of headphones that cost $85. You already have $20 saved. You earn $13 for every hour you work. How many hours do you need to work to afford the headphones? Let x be the number of hours. 13x is what you earn, plus the 20 you already have. Subtract 20 from both sides. Divide by 13. You need to work 5 hours. 13 times 5 is 65. Plus 20 is 85. Exactly enough. See how algebra just translates real life into symbols. And then you solve the symbols, and you get a real answer you can actually use. 5 hours. That is concrete. That is something you can plan around. One more algebra challenge before we move on. This one has fractions in it. Do not panic. Fractions in equations are just numbers. They follow all the same rules. X over 3 plus 5 equals 9. X over 3 means x divided by 3. Plus 5 gives us 9. So first, subtract 5 from both sides. Now multiply both sides by 3. Check. 12 divided by 3 is 4. 4 plus 5 is 9. here is a slightly trickier one. 2/3 of x equals 18. 2/3 of x, that means 2/3 times x. To undo multiplying by 2/3, we multiply by the reciprocal. The reciprocal of 2/3 is 3/2. X equals 27. Check. 2/3 of 27. 2 times 27 is 54. 54 divided by 3 is 18. Beautiful. Speaking of fractions, let us spend some time with them. Because fractions are one of those things that people decide they hate in 3rd grade and then just never give them another chance. But fractions are wonderful once you actually see them. A fraction is just a piece of something. 1/2 means you took something whole and split it into 2 equal pieces, and you are holding one of them. 3/4 means you split it into 4 pieces, and you are holding 3. That is all. Pieces of a whole. Now, adding fractions. This is where people get confused. You can only add fractions that have the same denominator. The denominator is the bottom number. It tells you the size of the pieces. You cannot add thirds and fifths directly because the pieces are different sizes. It is like trying to add apples and oranges. So 1/3 plus 1/5. We need a common denominator. The smallest number that both 3 and 5 divide into is 15. So we convert. 1/3 becomes 5/15, and 1/5 becomes 3/15. Now we can add. 5/15 plus 3/15 equals 8/15. Let us try another. 2/3 plus 3/4. Common denominator of 3 and 4 is 12. 2/3 becomes 8/12. 3/4 becomes 9/12. 8/12 plus 9/12 is 17/12. That is more than one whole. We can write it as 1 and 5/12. Multiplying fractions is actually easier than adding them. You just multiply straight across. Numerator times numerator. Denominator times denominator. 2 times 4 is 8. 3 times 5 is 15. The answer is 8/15. No common denominator needed. Just multiply across. And dividing fractions, you flip the second one and multiply. 3/4 divided by 2/5. Flip 2/5 to get 5/2. Now multiply. The reason flipping works is dividing by a fraction is the same as asking how many of that fraction fit inside the first one. How many 2/5 fit inside 3/4? 1 and 7/8 of them. It makes sense if you think about it slowly. And we have all the time in the world. All right, let us shift into geometry now, the world of shapes. And I want to really get into the details tonight. Formulas, calculations, all of it. Nice and slow. Let us start with rectangles, the simplest shape to calculate. The area of a rectangle is length times width. If a rectangle is 8 units long and 5 units wide, The area is 8 times 5, which is 40 square units. The perimeter of a rectangle is the distance around the outside. 2 times length plus 2 times width. Triangles. The area of a triangle is 1/2 times base times height. Always 1/2. Because a triangle is basically half of a rectangle. If you take a rectangle and cut it diagonally, you get 2 triangles. Each one has half the area. So a triangle with a base of 14 and a height of 6. What about a triangle with a base of 9 and a height of 11? And that is fine. Areas do not have to be whole numbers. The world is not always round numbers. Sometimes it is 49.5, and that is perfectly okay. Circles, my favorite. A circle with a radius of 10. Let us find everything about it. The diameter is twice the radius. 2 times 10 is 20. The circumference is 2 times pi times the radius. The area is pi times the radius squared. One number unlocks everything. Now, what about a circle with a radius of 3? Let me show you something fun. What if you have a shape that is not a simple rectangle or circle? What if it is a trapezoid? A trapezoid has 2 parallel sides of different lengths and a height between them. The area formula is 1/2 times the quantity of base 1 plus base 2 times the height. What about the area of an irregular shape? Like an L-shaped room, you can break it into rectangles. That is the trick with complex shapes. Cut them into pieces you know how to handle. Say you have an L shape. The bottom part is 10 by 4. The top part is 6 by 3. Okay, let us go deeper into trigonometry now. Because last time we just introduced the basics. Tonight, I want to actually use trig to solve real problems. The kind where you figure out distances and heights without ever measuring them directly. Remember our 3 friends. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, katoa. Problem 1. You are standing 100 feet away from the base of a building. You look up to the top of the building at an angle of 53 degrees. How tall is the building? We know the adjacent side. 100 feet. We want the opposite side. The height. We have the angle, 53 degrees. Adjacent and opposite. That is tangent. Problem 2. A ladder is leaning against a wall. The ladder is 20 feet long and makes an angle of 65 degrees with the ground. How high up the wall does the ladder reach? The ladder is the hypotenuse. The wall height is the opposite side. Sine of 65 equals opposite over 20. And how far from the wall is the base? Verify with Pythagorean theorem. Problem 3. This one is beautiful. 2 friends are on opposite sides of a river. One friend walks 80 meters along the bank, then looks across at the other friend at an angle of 40 degrees from the direction they walked. How wide is the river? Let us talk about special angles. There are certain angles whose sine and cosine values are worth knowing by heart. Notice that sine of 30 equals cosine of 60, and sine of 60 equals cosine of 30. They are mirrors of each other, complements, because 30 plus 60 is 90. Sine of 0 is 0, and cosine of 0 is 1. Sine of 90 is 1, and cosine of 90 is 0. They trade places, like two friends on a seesaw. When one is up, the other is down. All right, let us settle into quadratic equations now. The ones with the x squared. These are my favorites to whisper about because they have so much going on inside them. A quadratic equation looks like a x squared plus bx plus c equals 0. And when you graph it, you get a parabola, a U-shaped curve. The vertex is the lowest point of the parabola if it opens up, or the highest point if it opens down. The x-coordinate of the vertex is negative b over 2a. Let us factor some quadratics. Factoring is like reverse multiplication. You are breaking an expression apart into two pieces that multiply together to make the original. X squared plus 7x plus 12. We need two numbers that multiply to 12 and add to 7. 3 and 4. Another one. X squared minus 2x minus 15. We need two numbers that multiply to negative 15 and add to negative 2. Negative 5 and 3. The vertex is at x equals negative b over 2a. Here b is negative 2 and O is 1. Let us use the quadratic formula on a tougher one. 2x squared plus 3x minus 5 equals 0. Here A is 2, b is 3, c is negative 5. The discriminant is b squared minus 4ac. The discriminant is 49. That is positive and a perfect square. Now let me tell you about the discriminant and what it really means visually. The discriminant is that part under the square root, b squared minus 4ac. When the discriminant is positive, the parabola crosses the x-axis twice. Two solutions. When the discriminant is 0, the parabola just barely touches the x-axis. One solution. The vertex sits right on the axis. When the discriminant is negative, the parabola never touches the x-axis at all. No real solutions. Let us drift into something soothing now. Linear equations and how two lines can meet. Remember y equals mx plus be a straight line. The m is the slope, and the b is where it crosses the y-axis. Let us graph two lines and see where they meet. Line 1, y equals 2x plus 1. Line 2, y equals negative x plus 7. Where do they meet? We set them equal. The lines meet at the point 2, 5. The one and only point that lives on both lines at the same time. Let us try another system. 3x plus y equals 13, and x minus y equals 3. We can add these two equations together. The y's cancel. The solution is 4, 1. Check. 3 times 4 plus 1 is 13. 4 minus 1 is 3. Both equations satisfied. There is something beautiful about systems of equations. Each equation is a line. Each line is a rule. And the solution is the one point in the entire infinite plane that obeys both rules at the same time. Finding that point feels like finding a needle in a haystack, except algebra gives you a magnet. Let us talk about percentages for a little while. Because percentages are everywhere in your life, and knowing how they work gives you a quiet kind of power. Percent means per 100. 25% means 25 out of 100. What is 30% of 200? What is 15% of 80? Here is one people use every day. A bill of $45 with a 20% tip. The tip is $9. Total bill is $54. A jacket costs $120 and is 35% off. Percentage increase and decrease. If something increases from 80 to 100, what is the percentage increase? And if something decreases from 100 to 80, notice something interesting. Going up from 80 to 100 is 25%, but going down from 100 to 80 is only 20%. The percentage depends on where you start. That is a subtle and important thing. Here is something that uses percentages and exponents together. Compound interest. This is how savings accounts work, how investments grow. Say you put $1,000 in a savings account that earns 5% interest per year. The formula is A equals P times 1 plus R raised to the power of T. After 1 year, after 2 years, after 10 years, you started with 1,000 and ended with over 1,600. That extra $629 appeared out of compounding. Einstein reportedly called compound interest the 8th wonder of the world, and the math backs it up. Let me give you a few more proportion problems. Because proportional thinking is one of the most useful mathematical skills you can have. If a car travels 240 miles on 8 gallons of gas, how far can it go on 15 gallons? A recipe calls for 3 eggs to make 24 cookies. How many eggs for 60 cookies? If 5 workers can paint a house in 12 days, how long would it take 8 workers? Let me take you a little deeper into exponents. Because there are some rules that make working with them so much easier. Like shortcuts through a maze. When you multiply 2 powers with the same base, you add the exponents. When you divide, you subtract the exponents. When you raise a power to another power, you multiply the exponents. What about x to the power of 0? and negative exponents. The negative just flips it. Let me tell you about scientific notation, because this is where exponents become truly powerful. The speed of light is about 300 million meters per second. The distance from the Earth to the Sun, the mass of the Earth, and small numbers work the same way. The width of a human hair. Let us do some quick calculations. 3 times 10 to the fourth multiplied by 2 times 10 to the third. What about 6 times 10 to the ninth divided by 3 times 10 to the fifth? Okay, I think that is a good place to start winding down. We have been through so much tonight. Algebra with equations on both sides and fractions and word problems. Geometry with rectangles and triangles and circles and trapezoids. Trigonometry with buildings and ladders and rivers. Quadratics with factoring and the quadratic formula and parabolas. Systems of equations where two lines find each other in the void. Percentages. Exponents. So much. And none of it was scary. Was it? It was just math. Quiet, patient, beautiful math. One step at a time. One idea flowing into the next. I want you to know something. Every single one of these ideas, every formula, every technique, every method was discovered by a person. A regular human being who sat quietly with a problem and thought about it until the answer appeared. Pythagoras with his theorem, Euclid with his geometry, Al-Khwarizmi with his algebra. Actually, the word algebra comes from his book title, Kitab al-Jabr, the book of restoring and balancing. Restoring and balancing. That is what we have been doing all night. These ideas are thousands of years old, and they still work. They will always work. 2,000 years from now, the area of a circle will still be pi times the radius squared. Sine of 30 will still be 1/2. That is the gift of mathematics. Permanence. Truth that does not fade. So if you are still listening, take a slow breath. In and out. Let your mind be still. Let the numbers dissolve into the quiet. They will be there when you need them, waiting patiently, like old friends. And if you have already drifted off, then I hope the numbers followed you into your dreams. I hope you are dreaming of parabolas arcing across a night sky, of circles with perfectly measured radii, of two lines meeting at a single glowing point in an infinite dark plane. Good night, you did so well. I am proud of you. Let me count you down. Nice and slow. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Good night.